So here's a really interesting question with circular motion, and it states that a tape in a videotape cassette has a total length of 298 meters and can play for 2 hours. As the tape starts to play, the full reel has an outer radius of 41 millimeters and an inner radius of 13 millimeters. At some point during the play, both reels will have the same angular speed. What is this common angular speed? Well, let's first draw this. I kind of pre-drew some circles up here to show the tape rolls because I'm horrible at drawing circles. You'll see what I mean. All right, so let's say that this is the one that has all the tape around it. This guy's empty. I'll put a couple of guides over here. And so the tape rolls off of here. Oh, it's kind of like in a straight line. Goes around this and then starts to wrap around here. And they generally have like a tape reading head over here that kind of reads the tape as it goes along. And so this rotates this way while this guy opens up and unwraps the tape, and this guy starts wrapping it around itself. And so obviously they have the same linear velocity. They are connected together by the tape. And so as this guy rotates, let's say a distance of, or let's say a dot on here rotates and goes around once, during that time, a little dot on this edge would have gone around a couple of times, maybe 3 times as this goes around once. So this guy is going faster or rotating faster than this one is because this one has a higher angular speed. It needs to go around several times in the same amount of time as this guy goes around once so that it can keep up with the wrapping up of this tape that this guy is unfolding. So they have the same linear velocity. The little point in here will move at the same speed as that little point in there. It's just that this guy has a longer distance to go. This guy has a shorter distance to go, so it goes around several times. We are looking for the part where they have the same angular speed, meaning same degrees per second or radians per second. This is rotating, this should be rotating at that same thing. Now, we know that the linear speed is the angular speed times the radius. And so it makes all the sense that if omega is then v over r, then this guy has the smaller r, so he'd be having a larger omega or larger angular speed than this guy who has a larger r. Now, when is it that these two will be the same? Well, it's going to be the same when they both have the same r. Well, this little r here is 0, or let's say 13 millimeters. I won't convert it to meters. I'll leave it there. This is also 13 millimeters. And then this outer radius here is 41 millimeters. And this one again is 13 millimeters on the inside, and this one's 41 millimeters on the outside. When they are the same, they would have the same R. So at some point, when it's been playing, basically for an hour, because it's a 2-hour tape, and this point now, half that tape has rolled off the big guy onto the little guy, and now they're both equal. They both have the same R. If they have the same R, then by virtue of this, they will have the same omega, the same angular speed. Well, I'm going to call this capital R. And so if I look at this, when does this happen? When these two are equal, how could I relate this together? I hope you see that when this looks like this, the amount of tape that was on here, the area of this thing must now equal the area of both of these combined. That should make total sense because of the way the radii are. The radiuses become smaller, the areas will become smaller, but the total area of tape that I have here has to now equal to these two there because there's only so much tape. Law of conservation of tape. And so when these are equal, and I've called this capital R, I could say that the area of this is equal to the area of those two combined. How would I write that? Well, the area of this whole thing is pi times R2 squared, or R2, I'm going to call this one R2, and this little one R1. Okay, so that's also R1. The little one is R1, and the large one is R2. So the large area, which is pi R2 squared, minus the little area, which is pi R1 squared, gives me the total area of this. That should equal to, and because there's two of them, I'll put 2 over here, times pi R squared minus this pi R1 squared. And so now I have R2 and R1, and I know what pi is. So all I got to do is solve for this R. I can rewrite this as pi R2 squared minus pi R1 squared equals 2 pi R squared minus 2 pi R1 squared. Now adding plus 2 pi R1 squared to both sides. It's gone. And that leaves me with pi R2 squared plus pi R1 squared is equal to 2 pi R squared. I'm going to divide both sides by 2 pi. And so I have pi R2 squared plus pi R1 squared all divided by 2 pi is equal to R squared. The pi's cancel, leaving me with R2 squared minus R1 squared over 2 square root is equal to R squared. Then I can plug in my variables and figure out what this R is. And so I have, I'm sorry, that's a plus. I have 41 squared plus 13 squared all over 2 square root. And that gives me 30.4 30.41 millimeters. So that's the new radius. Now at this radius, both of them will have the same radius, which is 30.41 millimeters. So they will also have the same angular velocity because the linear velocity is the same. Now they have the same radius, so now they will also have the same angular velocity. So that's the R at which it's happening. We don't need to just find the R, we need to find out, well, what is that common angular speed? Well, we know that the linear speed, because 298 meters plays for 2 hours, that would be 298 meters divided by 2 times 3600, converting the 2 hours to seconds. And that gives me 0.0414 meters per second. So using this relationship, I can find omega. Omega is just V over R, which would be 0.0414 meters per second divided by, I'm going to convert this to meters because I've got meters up here. That becomes 0.03041 meters, and that gives me 1.361 radians per per second. Okay, so that's the speed at which these will go at the same, will have the same um, linear velocity and the same angular velocity. And that angular velocity would be 1.361 radians per second. Okay, it's kind of cool. And again, um, reading the question without drawing out the picture makes it really hard to do. So make that a habit. Every time you read a question, draw a picture to visualize what's going on and start putting everything down, and you'll suddenly see that you can figure out several different ways to work out it. All right, well, that's the end for this one. Thanks for watching. Catch you in the next video.